as a basic calculator. Any form of calculation, you can use our programming language for it. So before we move on, I will want to explain some terms we will be using in now for us. So the first one here, I have C. So you can see here, I have C, then two brackets in front of it, open and close bracket. Now this C is used in our programming language when we have many factors, when we have more than one factor. We use C to combine more than one factors together when we want to assign particular factors to a variable. Then another thing I have here is rep, REP, just like repetition. So to repeat elements or patterns. Then the next one I have is SEQ. So SEQ is sequence. So this sequence is being used when we want to save our time, just like manipulation. Let's say we want to write 1 to 9. So we can easily skip some numbers between that 1 to 9 using this SEQ. So to start, so how as a calculator. Now, I believe if not all of us, some of us will have installed our program, like our package on their systems. So let's start with our as calculator. This is our console. So if you check at the top here, I have my script. So there are a lot of things you can use. We have our script, you have our markdown. If you check, look at what I have here. So I have our script, our markdown, our Swift, HTML, and presentation, our D file. So all these are what you can use with R when you want to write anything. So you can just easily write your code here and save it. So then to start as our basic calculator. So you can easily say 1 plus 1. So 1 plus 1 for R will give you 2. You get any form of calculation you want to do now, you are free to do any form of calculation. It will give you the answer you want. So let's say 2 multiplied by 3 multiplied by 4. You can see how easy it is. So just to run the code and get your answer. Then another thing here is, let's say you have X. Now I want to assign, I've said it earlier that if I want to assign many factors to a particular variable, I'll be using C to combine them together. Now, for example, let's say I want to have X is equal to 2. Now I have only one variable here, like only one factor here, which is 2. So if I run it, now if I call out my S, it will give me 2. Now I've assigned these 2 to S, that okay, anywhere I see X, like X will be taking place of 2. Now you know because I have only one vector here, I don't bother to use any C at all. But if in a situation that I will be having more than one vector, so let's say I have X is equal to C, then into bracket. So I have 2, 4, 5. Now here I have 3 vectors. So if I run it like this, so now if I call out my S, now I have X to be 2, 4, 5. X to be 2, 4, 5. Now check, let's take my example. Let's say if I have X is equal to now 2, 3, 4. You know, I didn't include any C here. Now let's see if it will run. Can you see you have an unexpected error because you don't use particular terms that we need to combine it together. So in short, if you are combining many vectors together in now, you have to use particular terms. There are a lot of terms you use C, you use rep, you have list. We'll be taking ourselves through each everything one by one tonight. So then another thing now, let's from what I have earlier. So I assign these 2, 4, 5 to my X to be my X. Yeah, and I've called out my X to be 2, 4 now. There are something we call subsets. Now, let's say I want to subset, I want to do subsetting in this X now. If I want to do subsetting in this X now, I can easily say X, then use square bracket. Now, if you notice when I include brackets, But when you want to do subsetting, you use square bracket. Now, and that's a subset of 2. Now, subset of 2 here will give me 4. Now, why? Now, anything you have, when you are assigning factors to particular variable in R, now if you start counting it one, if you check now, you can see my cursor here. So these 2 will be our number 1, then this 4 will take 2, then 5 will take 3, and so on like that. If you have another number, it will take 4. So this x into square bracket of 2 is telling me that I want to subset number 2 of those 3 factors. So which is 4. If I do x subset of 3, so it will give me 5. Now I'm subsetting number 3 factors out of the. Now I can use positive for the subsetting, then I can also use negative. Now let's take, for example, I want to use x, then subsetting of -2. Now can you see what I have? I have 2 and 4. This -2 is telling me that I want to remove only the number 2 factor from the whole factors. So it will give me the remaining factors, removing the number 2 factor. If I'm subsetting -1, so let's say x into -1. So it will be giving me the second factor and the third factors. Are you together, please?
Yes,
Hello?
we are together. Yes, speak
Okay,
on, sir. We are together.
okay. So then after then we have we can have our square root of 9 will give me 3. Same thing as square root of
Hello, can you share
49.
sir?
Okay.
Hello. Thank you.
Yes, I'm with you. Can you see it now? Can you see my screen, please?
Not yet.
Hello?
Yeah, it's visible now.
Can you see my screen?
Yes. Speak on, sir.
Hello?
Screen now. Yes.
You can see my screen?
Sir. Yes, continue.
Yeah. Thank you. So now let's say I want to do square root of 49. So use SQRT of 49. So it will give me 7. As you know, 7 is square root of 49. Now let's say we want to do square of this 7. Let's say we want to do square of this 7. So what we just need to do 7, then raise power of 2. So you have 49. So and pi is 3.142. So if you want to run just pi in your house now, you have 3.142. As you all know, normal number for pi is 3.142. Here is rep. Now let me take us through this rep. Now if you want to use this rep now, you can say rep of 1,4. Now this rep of 1,4 is telling me that I want to repeat 1 in 4 places, in 4 times. Now this is it. So instead of me to be writing 1, once you just write rep of 1,4 to replace, there are some times that let's say you want to have rep of now 2. You now want to write 2 in 10 places. Before you be writing 2, if you take just write 2, 10. So rep of 2, 10 will give you 2 in 10 places. Then So after I want to use rep of 2 comma 4, 2 to 4. My screen. We explain two things here, so which are sequence and the rep. Now I've made mention of sequence before, which is SUK. Now when you have a particular number, let's say the way I have 2, then column 4 here is what I mean by sequence. Now before I do this, let me just write the code on this sequence of the thing. Now let's say I have sequence of 1 to 4. Now this sequence of 1 to 4 is telling me that I want to write number from 1 to 4. Instead of me writing it one by one, like okay, 1, 2, 3, 4. Now this sequence of 1 to 4 will give me all the number between 1 and 4. Are we together, please? Now I now want to use this sequence together with rep. Now I have rep of 1 to 4, then comma 5. Now this rep of 1 to 4 comma 5 is telling him that I want to write 1 to 4. No, that's the first code here, which is sequence. Me in 5 times, like I have 1 to 1 column 4 comma 5. So I will be right, it will give me 1 2 3 4, then in 5 times. So it will give me 1 2 3 4. So that will now be in 5 places. 5 places. Now I now have 1 to 4 comma each is equal to 5. What I'm saying here is that it will give me 1 1 1 1 5 times, 2 2 2 2 5 times, 3 3 5 times, then 4 5 times like that. Can you see the difference here? Now, then I think I've explained the sequence. Now another thing you need to know under sequence is that you can have sequence of, let's say I have sequence of 1 to 8. Now I have sequence of 1 to 8. Sequence of I have sequence of 1 column 8 comma by 2. Now what I'm asking how to do here is that I want to list number between 1 and 8, but it will be giving me intervals of 2. In the first place, there's an issue there. Okay. 1 comma 8. No. Now this is it. So I have 1 comma 8, then by 2. Now for sequence, I have 1 comma 8 by 2. Now what I'm asking now to do here is that initially 1 to 8. The sequence of 1 comma 8 is to give me number between 1 and 8. Now I now say by 2. This by 2 is that it will be giving me an interval of 2 to 2. Like 1 2, it will skip that 2, then move to 3, then skip 4, move to 5, skip 6, move to 7. You can give it any interval you want. So mostly we usually use all those things. Probably this by 2, then rep. Most time when we are doing statistical modeling. So just to save some stress when you are coding some things. So usually use all these things. Then another thing we have here, you can use R to perform mean, median, and all those things. Let's say I have my S. I think I've defined S before. Now this is 245. Now my X here is 245. So I can easily say I want to know the mean of X. I can easily say I want to know the mean of X. So which is 3.6. As we all know, the mean is summation x over n, which is addition of these 3 vectors divided by 3. So that will be 2 plus 4 plus 5, then divided by 3. So I'm having 3.666. Now there are some times that in your data, you'll be having some missing values, and you might want to check the mean of those values. Now there is a way you have to do that. Now let's say I want to assign these vectors. Let's say I have 2 comma 4. I have 2 comma 4 comma 5 comma NA comma 4, NA, 9, 8. Now, in this situation, you see, I'm having NA as part of my observations. Now, this NA is missing value. So most times, when you are dealing with some kind of large data, you'll be seeing some missing values there. So it will be represent, it will be NA will be using to denote those missing value in R. Now, I have NA. Now, already I've assigned all this value to be my R. Now, if I want to check the mean of this value, automatically it won't give me correct answer. Now, let's say I want to check the mean of R. Now, can you see I'm having NA? That means there is a kind of missing value there. So, R cannot give you the mean you want until you remove those missing values. Now, there are some codes you can use. There are a lot of methods we use when we want to remove missing values in that. But basically, I will just, since we are just having an introduction class, so I will give us the basic way to remove missing value. Now, which is, now I can easily say I want to look for mean of R, then comma NA, mean of R, comma NA dot RM is equal to true. Now, this code I'm having here is that mean of R, already I've assigned these values to be my R. Now, I want to remove the missing value among this NA.rm is remove, like NA.rm is code we use to remove missing value. Now, I have NA.rm is equal to true. It's telling me that any missing value I have here is to remove it, then go on with calculations I need. Now, can you see I have answer for it now? So that means it has removed the two missing values I'm having in my observations here and give me the mean that I need. Are we together? Please, if you have any question, you can ask your question. So that means it has removed the missing values I'm having. So likewise, the way you look for mean there, you can also look for median. So let's say I want to check my median. So same thing. So if you give me the value for median as well. So I didn't add this NA dot remove when I want to run this median code as well to return NA for me, because I will not be able to calculate anything when you are having missing value in your observations. Generally, while doing programming in any programming language, you need to use various variables to store various informations. And variables are nothing but reserved memory location to store values. This means that when you create a variable, you reserve some space in memory. Now, what do I mean here? When you are dealing with any programming language, so it's a must. You'll be storing some variables till you will be needing them. You get now. Let me just give us some example here. So to start now, I'll be telling us the types of data types we have in now. So in now, we have data types, and the data types we have here, I'll be explaining 5 data types here for us. Now, the first one is logical. I'm talking about logical in now. It's just it's telling us we take our logical in now is true or false. True or false. So yeah, there are some times that you'll be running some code and it will return either true or false for you. So those kind of data are logical data. Now let's say I have my y is equal to, now that, now the first way is you write everything in capital letter. So as you can see, I have capital T, capital R, capital. Now, if it is false as well, you write everything in capital letter. Then the second way is just write capital T or you write capital F. to give you the same thing. Now I'm assigning y to be my true now. So if I want to call out my y, you see the, so can you see I have true. Now I can check the class of my y. If I want to check the class of my y, so class of y, so to give me logical. Can you see? It's giving me logical, telling me that the values I've assigned to this y is class of logical data. Then the next data type we have here is numeric. Now, what we usually know is that any number is numeric, but not like that in our programming language. I think same as Python as well. So in numeric, in our program language, our numeric is just number, any number, like any number without alphabet. Now let's say I have G is equal to 55. You get? So this is numeric. I can have a lot of numeric. Check if I believe you can all see my cursor here. So we have 22, 20.56. All these values are numeric, they are in class of numeric. If I combine them together or I'm writing them one by one, they are still in class of numeric. Now if I check the class of G here, the class of G, can you see, is telling me that it is numeric. Then the next data type you have is integer. It's 2L. It's usually denoted using L, capital L. Now it can be any number. Let's say I have G is equal to 4 capital L to capital L. Now the class of G here will give me integer. So any number you write and you include capital L to it in our program language, it will return class of integer. Then we have complex number as well. As we all know, our complex number is 2 plus. I think we have all done mathematics before. So probably in our 100 level and 200 level days. So I have complex number. And my complex number can be so 2 plus 4i. So just normal I. So if I check for the class of E, I have complex number. Then the last one, but not the least here, is character. Now character, any values or any text you write in our program language, once you include two, yes. So once you include apostrophe to it, you are referring to class of character. Now it can be 2 quotes, it can be double quote, it can be 1 quote. Now let's say I have B is equal to, so I have F here. Can you see? I'm having double quote here. Now if I check my class of B, I have character. Now anything you write in now, it can be numeric, it can be integer. Once you add inverted comma to it, be it double, be it single, it will change the class to character. Now there are some ways. Probably you have you have numerical data or character data, the observation data character, and you would like to change them to numeric, or you have characters and you have numeric, you will have to change them to characters. So there are some codes you usually use for those ones as well. Now let's say I have y is equal to 22 plus 3. Now let me check the class of my y. No, this will return numeric for me. Now this is numeric. Now I can easily change this class of y from numeric to anything I want. I can change it to logical. I can change it to character. I can change it to anything I want using some code. Now I can say T is equal to AS dot character. AS dot character. So of Y. I've checked the class of my Y and it returns numeric for me. Now I want to convert this numeric class to character. Now can you see? I've assigned this AS dot character of Y to T. So this code is telling me that I want to change this numeric class to character class. Now if I check the class of T here, you see it will return now class of T to return character from. Can you all see? So I'm having character, it's returning character from that. I've changed it from numeric class to character. Now, all these things, we have logical, complex. Now, there are some times that, no, let's just say they are all in gradual process. One is powerful than the other. So, in this case, all the 5 data types I have here, character supersedes the remaining 4. Now, let's test for it. Now, let's say I have W is equal to. Now, I now want to combine all those. First one is numeric here, representing numeric. Then I have the one representing integer. So let's say I have the one representing logical. Then I have the one representing character as well. So representing character as well. Can you see? Now I'm assigning all these observations to W. Now let me check the class of W. Can you see that it return character for me? Now, why? Because character supersedes all the remaining classes we have here. So it's telling us that we have 5, like we have numeric, we have logical, we have integer, we have complex, we have character all together. Character supersedes the remaining 4 classes. So it will return character for you if you are combining everything together. Vector now what are vector? When you want to create vector with more than one element, you use C. Now I've explained the reason why we use C before. Now when you want to create vector more than one element. Now what is vector? Vector is just normal text, be it text. It can be text, it can be number, it can be anything. Once you just combine them together, so you have to use C. Now let me assign. Let's say I have name. It's got to C into bracket. So I'm having Olu, Tunde, then I'm having Peter. So all these text, they are vectors. So that means I'm assigning these 3 names to be under my name. Now I can easily assign them. Then you have to. Now if I check the class of this vector now, definitely you should know that it will return character for me since I'm having quotes at the top of it. So it can be 2 quotes at times, it can be 1 quote at times. So just know that it will return character for you. So that's just vector. So vector is just the basic data structure you have. Then another one we'll be talking about is list. Now list, for the list, a list is an R object which can contain many different types of elements inside it, like vectors, function, even. Now what list is telling us is that in vector, when you want to do vector now, I have only one class of like I have a particular class assigned to name under vector. Like all class I have here, they are just character. But when it comes to list, you can have like as many as possible classes you want. So you can have numeric, you can have logical, you can have characters inside one box when you are dealing with lists. So list can contain as many possible as classes you want to assign to it. Now so I have U is equal to so C. So
Can
please,
you
I'm
please share
sharing my
your
screen. I'm sharing it now. It's next row. Okay. I believe you can see it now. So here, this list. So I'm having three classes. So I have numeric, I have character, and I have integer. So I can add logical to it as well. I can add logical to it as well. So list can contain anything. If I now you have to notice something here. You have to notice something here. Now if I call when I call out my list, you can see it convert everything to C. It can convert everything to character. Now this is just you. I'm just calling out only you. Now let's say I want to use my list now. Y is equal to you now see the difference between so I have list of so Jewel. So I have probably a day. Then I have to now let me call out my Y. Now can we notice anything here? When I call out my list, it's display them one by one. Unlike the first one, when I use only C, I use only C in the first U I call out. So I have everything in on the line. But when I use list, it return them one by one, not together. Now that's the difference between you. Now this list, the reason why it return everything one by one is that it's telling me that I'm having different classes of, not that I have only one class. But if you are not using list here, that means it will classify all the classes you have in a box as one. But when you use list will tell you that everything you have there, they are not the same class. So it will return them in different line. Are you getting it, please? So it will return them in different line, not in a single line like the others. So list will tell you that everything you have, like it can contain any kind of classes you want to add to it. So that's just the list for us. Then we can move to matrix. So you can use R programming language to perform matrix as well. So now, how do you run the code? Now, let me just give all them. A matrix is a two-dimensional rectangular data set. It can be created using vector input to the matrix function. Now, if you check it, I'm having two. The same matrix is a two-dimensional rectangular data set. What are the dimensions of matrix? Row and column. Row and column. So they are just two. Just two-dimensional for matrix. Now, if I want to do matrix now, so I can say E is equal to, so I have matrix of then C of, so I can say uh 1 to 9, then number of row is equal to 3, number of column is equal to 3. What's happening? And no, E is equal to matrix. Okay, okay. Oh, sorry. Now, this is a code to all matrix. Now, let me explain it one by one. So, I have n is equal to matrix, then C into bracket 1 to 9. Number of row is equal to 3. Number of column is equal to 3. Now, what I'm saying here is that I want it to return number from 1 to 3 for me, 1 to 9 for me. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the first thing we have here, which is 1 to 9. Then n row is number of row. The number of row I want to have in the matrix should be 3. Then the number of column I want to have in the matrix should be 3 as well. Now, by default, if you write the code like this in R for matrix, so how we arrange it column wise, it will arrange it column wise for you. Now let's check what I'm saying. Can you see I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it arranges it column wise for me. Now let me now run another code. Let me just add by row to this. By row is equal to true. Now, what I'm saying here is that I don't want how to arrange it column wise for me. Instead, I want it to arrange it row wise. Now, let me call out my n, and you can see the difference here. So, in the first matrix, you can see I have 1, 2, 3 column wise, 4, 5, 6, 7, 8, 9. Then for the second matrix, I have 1, 2, 3, 4, 5, 6, 7, 8, which is they are arranged row wise, while the first one are arranged column wise. So, if you want to write a code for matrix, so it depends on how you want it to be. But if you don't include by row, definitely by default, it will arrange it row wise for you. It will arrange it column wise for you until you add by row before it can arrange it row wise for you. There are a lot of ways you can use to write codes on matrix. So another way is that let's say I have T is equal to, so I can say I have matrix of so C, then into bracket, so I can have 2, 6, just any numbers. So 1, 2, 3, 4, 5, 6. So 1 n row is equal to 3. N column is equal to 3. Nothing to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. Of is equal to matrix of brackets 2, just save our time, n row is equal to 2, n column is equal to 2. Now, if you check the code I have here, when you are writing any code for matrix, you have to take notes the number of row and the number of column. Let's say you want to assign it to be 3 rows and 3 columns. So definitely you should know that you must have 9 observations there. Now, if you are having anything beyond 9 observations or anything less than 9 observations, and you are writing code of 3 rows and 3 columns, definitely it will flag error. As you can see the first one. So for 3 by 3 matrix, you have to have 9 observations. For 2 by 2 matrix, you have to have 4 observations like the second one. Then when it comes to 4 by 4 matrix, you have to have 16 observations like that, and so on like that. Now, the first 2 code I ran here, I just used 1 to 9. But I don't want to use 1 to 9 again. So I have 1 to 2, 4, 5, 1. So and this is 2 by 2 column. If I call out my F. You see how I have it. So this is 2 by 2 column matrix. Now there are several ways you can do subsetting in matrix as well. We have made mention of subsetting earlier. Then you can do subsetting in can do subsetting in matrix. Now let me call out my N for better clarification. Now I want to subset I want to do subsets of these 5. Like I want R to return this 5 for me. This is only 5 now. I'm having this 5 as the second row and second column. Now how do you subset for it? So you can just say your N, then always you will be using square brackets for the subsetting. Now 2, 2, 2, 2. Now the first two is telling me the row, and the second two is column. The first two is the row, the second two is the column. Now if you please follow my cursor here. So you have square bracket of 1 comma 2 comma 3 comma. Now this 1 comma, if you subset this 1 comma, it will give you all the values in the first row like this. Now let's say I have N of 1 comma. Can I also say I have 1, 2, 3? So let's say I have N of 3 comma N of comma 3. Can say I have only the observations under the 3. So if you want to subset particular observations among all these observations, so that means you'll be using the row and the column together. But if you want to subset particular row or column, so you'll be using either comma 1 or 1 comma, either comma 2 or 2 comma, like that. Are we together, please? So you can perform matrix multiplication, matrix addition, and so on in using R as well. Now how do you do that? You have two matrices before. Let's say I have N. This is my N. I call out my N. So I can have another matrix. Let me call it R, which is matrix of I can say 2 to 10. So I have NO to be 3 as well. It's equal to 3. N column is equal to 3. What's happening? Okay. Please, you have to take note when you are running some codes. You have to take note of little mistakes that will be coming up most times. Two to 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm having matrix Can I now see? Now, so I have D. So I have D and I have N, which are two matrices. So if you want to do matrix multiplication, the number of your row and the number of your column in the both matrices must be the same for the multiplication. for the addition. So the first one I will be doing, let's say I have G, then plus N. Now you all see, now I have 2 plus 1, which is 3. 3 plus 4, which is 7. Then 4 plus 7, which is 11. 5 plus 2, 7. 6 plus 5, 11. Then 7 plus 8, 15. Like that. So you can do the multiplication same way. Just do the addition like that. Can you see it like this? So you can do it like that. Then there are some other terms in matrix, like determinant of matrix, all those things you can just perform them. So can you see? I'm having the determinant of G to be 0 because of the observations I use. So how did we use right observations? So we might have a reasonable number. You get, so you can just do as many things as possible using our programming language. So not to waste our time, we have a lot of things to do. Then we move to array. Now array, why matrix? So for the array, why matrices are confined to 2 dimensions, array can be of any number of dimensions. The array function takes a dimension attribute which creates the required number of dimensions. Now the difference between array and matrix is that matrices have only 2 dimensions, which are column and row. But when it comes to array, arrays have more than 2 dimensions. So you can use, you can let's say, okay, for example, I have W is equal to, so array, almost the same way you write the code for the matrix. So array of, so I can say probably like I have let's say I have Ola, then Tunde. So now dimension now be equal to C into brackets 3, 3, 2. Now the code I write here is that I want this array to, I want how to return it from that, okay, Ola and Tunde, it will give me, it will return it in 3 rows, which is this one, 3 rows, 3 columns, then 2 dimensions. 2 dimensions is that it will repeat it twice. Like after the 3 rows and 3 columns, it will now repeat it twice. Now this is what I'm saying. You can see I have Olatunde, 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 Olatunde. Now by default, array, how arrange array column wise. You can't use by row in array, unlike the matrix. You know, when you are writing code for matrix, you add by row. That is when you want to change it from column to row in terms of arrangement. But when it comes to array, automatically it will be arranged column wise, and you can't use by row for it. So it's by default to arrange it column wise. Now this is what I'm saying. I have Olatunde, Olatunde, Olatunde. Now the difference between array and matrix is that, you know, here the way array return twice output for us, matrix cannot do that. That's the first thing. Then another thing is that when array stop at 1, like the first observation, now let's say it stop at, can you have Olatunde, 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 Olatunde. Now the last observation here, the last one we have here is Ola. Now it starts from the next, starts the remaining from the next dimension. So instead of it completing Olatunde here, it now starts from Tunde here. I believe you can understand what I'm saying. We understand what I'm saying. So after that one, another thing we can do in array, you can do subsetting as well in array. Now the subsetting in array, let's say I want to subset this Tunde now. Let's say I want to subset this Tunde now. You know, this Tunde is in first dimension, third row, and second column. third dimension, first dimension, third row and second column. So for me to suspect it now, so I just say okay, W, then square bracket of third row, which is 3, column, second column, which is 2, and first dimension, which is 1. So to give me 20. So like that. If you want to do for all out, just notice the note the row, note the column, then note the dimension, and that's all. Then there's another way you can code array when you want to use array now. And no, here it's give us the labeling for this array. You just have 1, 2, 3. Now there is a way you can just give them names if you don't want it to be 1, 2, 3 like this. Now let's say I have F is equal to, so I have C, then to bracket 4, 1, 8, first one. So I have G is equal to C into bracket. So I can say I have 3, 8, 9, 1, 3, 2, 1, 2, 3, 4, 5, 6. So second values. Now I can say I have columns dot name. So it's equal to C into bracket column 1, or then column 2. Then for column 3 as well. So I want this one. So O dot names is equal to C into brackets, okay, row 1, comma, then I have row 2, then I have row 3, like that. So then I can have matrix as well. Matrix dot names. So it's equal to C into brackets. So I have matrix 1, comma, then matrix 2 as well. Now all these things I can combine them together in one array. Now I have E into, so array, then you open bracket for that, so which is C. So my first two values, which are F, then comma G. So outside the bracket, so I have the dimension. So how many dimensions do I want it to be? So as I'm interested to know the number of observations I have here are 9, so I can just make it 2 dimensions, 3 rows, 3 columns, and to be 2 dimensions. Then dim names, these are my dimension names. So since there are many, so I can just use list to combine those ones. This with so I have column names, comma, row names, row dot names, then comma matrix dot matrix. Can we see? So I have E. When I call it out, no, it has changed for me to be row 1 now. Now this is the first code. So now I want to check something here, so you can notice the difference between the two. I have row and I have column. Now I call out my E again. Can we see the two? Now in the first output, I have my row to be In the first output, I have my row to be at the top, then column to be at the uh beside of it. So these are the column, these are the row, and the next the last output. So I have my column here at the top and the row. So it depends on your arrangement. It depends on your arrangement. If you check the first arrangement, now the first arrangement I use, the column comes before the row, while the second arrangement row before the column. So it depends on your arrangement, depends. So there are most times you might have interest in not using either this row or column for your labeling. So you can just decide to use anything you want for your labeling. So just know the way you arrange it and you have what you want. So then that's how we can use another thing for the array. Then another thing I will be taking us through here is data frame. Now, data frame is necessary in how is an important aspect of our programming language. Data frame is an important aspect of our programming language. Now, what is data frame? Now, data frame are tabular data objects. Unlike a matrix in data frame, each column can contain different mode of data. The first column can be numeric, while the second column can be character, and third column be logical. Now, if you notice all this code we have been using before for the matrix, you can only have one class of data. If you want to use numeric, you use numeric or true. If you want to use character, use character or true. But when it comes to data frame, if you want to have three columns, the three columns can be different classes. They can be numeric, they can be logical, they can be characters. They might be different class, and it will give you what you want. Now let's try to give a code on data frame. So I have how slot to data.frame, data.frame. So I have first one, let me name it age. So to be equal to, so I have my age to 23, 15, 18. So the second one, I can name it gender. So I can make it to be gender. So it's equal to NC. So as you know that our gender can either be male or female. So another one, let's say I have female. Then another one, let's say I have female as well. So I can have height of the student as well. So height of the student as well. It can be 5.6, 7.3, 8.2. Then I can have, let's just leave it like that. Can you see? So when I call out my R, so this data frame, as you can see, it's return the outputs for me in tabular form. So I have age, I have gender, I have height, like that. Now, one disadvantage of data frame is that the way I have the same length for the age, I have 3 observations for the age, 3 observations for the height, 3 observations for the gender. Now let's try to remove one of the observations here. Can you see? It will never run. So that's one of the disadvantage of the data frame. So you cannot have different observation length. So your observation length must be the same, but the classes of the observations might be different. That's just the thing about data frame. Then in data frame as well, you can do subsetting. Now if you want to do subsetting in data frame, so my first code which I was using now. Now I have age, gender, and height for data frame. Let's say I want to call out only this height. So what you just need to do is how, then use $sign of the values you want to call out. As you can see, it pop up the three vectors I have under it. So let's say I'm interested in calling out height. So can you see I'm having only the observations under height. You get same as well. If you want to call out observations under, and I want to call out gender this time around. I want to call out gender this time around or age. Can you see I'm having observations only age. So that's data frame. So you can do a lot of things, lay your hands on it. So then let's move to another thing we have here. This data reshaping. Now data reshaping now is about changing the way data is organized into row and column. Now, unlike our data frame now, there are some ways as well that you can use to combine your data. Now, let me try to have some observation outside there. So I have W, then C. So let's say I have 32, 66, 12. Now I load it. So I have G is equal to then C to bracket. So 21, 97, 42. I load it as well. So I have F is equal to C. So this time around, I want to use character. So as you can see now here, if I want to combine these three observations, I can use these three classes. Now I have numeric, then character. I can use data frame. Now if I want to use data frame for this, I can say Q is equal to data dot frame, then into bracket of W, G, F. As you can see, I have my data. I have W. Now, the other way of combining observation, if you don't want to use data frame, now I can use C bind. Now, another way is using C bind. Let's say I have B is equal to C bind. C bind is column bind. So, it's column bind. So, I have W, G, F. Now, let me call out my B. Can you see it? Now, can you see the difference between the two? Now, in data frame give me sensible tabular table. Like there's nothing like adding it, giving me apostrophe on it or anything. But when it comes to C bind make all the observations under it to be character. It makes all the observations under it to be character. But data frame to return a normal table for you. But C bind. Then another thing you can use out bind as well. Now let's try to use out bind instead of C bind. C bind is out bind, column bind, where out bind is row bind. Now let's see the output. Can we see? Now here we have our W here, G here, F here. But when it comes to row bind, can you see W, G? But it's combined, it's make our observations to be character as well. So that's just the difference between C bind and column bind and the data frame as well. So the best way, if you want to have a table that will make sense, just go for the data frame. That's just the best. Then let's just take ourselves to little visualizations before we end this class. So let's say I have age of some students. So I have 32, 25, 15, 64. So let's say I have ages of 4 students. Yes. So I can easily do plus. I can plus a scatter plus for them. So age. Now see, let's check our plots. So can you see? So this is telling me that our data here is not normally distributed. Our data here is not. Now let's check another plot. Let's I believe you can see this plot very well. You can see this plot very well. You can see how the our plots look like. Then let's try to have another plot. So let me say I have D is equal to and I have C. So probably and I have 23 to 29. Because now I have to have plot of this. Can you see? Can you see that I have this one on a straight line? So whenever you have your plots on a straight line like this, it's telling you that the data you use are normally distributed. Telling you that the data is normally distributed. As you can see, they are on a straight line. They are on a straight line. I'm having my plots on a straight line. So there are some times that let's try to when your plots are on a single line like that, when they are on a straight line like that, it's telling you that your data are normally distributed. So there are a lot of plots you can use. You can have on our program line. So you can have scatter plots, box plots, histogram, pie chart, and the rest like that. So our program language will give you a kind of law that makes sense and very visible compared to the visualization on spreadsheet like SPSS and other things. But since this is just an introductory class, so let me just try to give us some things on the now. Like the first plot we have, which is D. So I can add some things to it to make it more meaningful, like adding color to it. So I can say I have blues, so blues of 9. Then when I run this, blue dot here is because I use my color to be blue. And if you check very well, you see that those dots, those plots, they are very very small. So there is a way you can just increase the dot to be more visible than this. Now let's try it, please. So if you want to try that, so I can say I have my PCH. So it's got to probably 20 like this. So my visible compared to the first one you have now. So there's something we call PCH when you are doing visualizations in R. So this PCH will allow you to increase to make your plot more visible than before. So this is the code I use. So I have two. First thing is plot, then D is my data. The data I use, which is C of 23 to 29, the ages of students from 23 years to 29 years. Then I have color. I use color to be blues 9. Now how when you are using when you are performing visualization in R, you don't just pick any color. So there are some default color in now. So normally I have color blue, color yellow. I will have used color blue, but I will not take that. So you use blues 9, so you have a lot of colors in now. Then I use 9. Then this PCH, it depends on the number of the PCH you have that will make your plot to be more bold. And don't forget, you only use PCH when you are dealing with something like scatter plot like this. So just to make our dots to be more visible and very bold. So when I increase, the more you increase your PCH, the more the visualization become like very bold. So that's that about the plot. So I think